recording while it goes. All right. What do I do first? Subtract 4. What does the 4 go with on the other side, or does it go with anything? Yeah, it's a like term with that minus 5. So that's going to combine to give us 4x squared minus 9 equals 0. And then I look for a GCF. Not 1. Then I look at how many terms I've got. 2 with a minus sign in the middle. The only way that can factor is if that is a what? Difference of squares. Can it be rewritten? Something squared minus something squared. What squared gets me 4x squared? 2x, right? What squared gives me 9? 3. I think we did this one yesterday. What does that mean my factors are? They both have 2x and there you go. All right. What do we do with each of those? Set them equal to 0. 2x minus 3 equals 0. 2x plus 3 equals 0. Solve them. X is positive 3 over 2. Don't give me a decimal. Leave it as fraction. And then negative 3 over 2. Not too bad. Pretty easy. Well, they're just different. I don't know if it gets any harder. It's just the numbers is the only thing that makes it harder, really. Yeah, sure. That far enough? I get you. Okay. Let's see. What letter are we on here? D? All right, good. All right, well, let's get one of those other scenarios that could happen here. What if it was something like 3x squared is equal to negative 12x? Seems simpler, but sometimes these are the ones that give us a little bit of an issue. What would be our first move? Yeah, move that 12x over. I would add the 12x. Technically, legally you could move the 3x squared too, but you don't have. I would, if it's already positive, I'm gonna leave it where it's at because it makes it easier to do. So I'm gonna add 12x. Okay. Now that was a little different because it's not obviously it's not a difference of squares because we've got an addition sign in there. All right, so it's in descending order. The next thing we look for is a greatest common factor. For this one, what's the GCF between 3x squared and 12x? 3x. And that leaves what in the parentheses for this one? X plus 4. Will this factor any further? No, it's x plus 4. It's as plain as it can get. So what do I do with each of those factors? Set them equal to 0. This one has an x in it, so I'm setting 3x equal to 0. And then the x plus 4 is also equal to 0. That's where a lot of folks forget, that one matters too because it's got a variable. Okay. What times 3 gives me 0? 0. So x got to be 0 for that one. And this one is x equals negative 4. Just by doing that subtraction. Technically, you're dividing by 3 here. But I think we're all to the level where you should be able to just think those one-steppers. Just think them. Let's see here. Get one that does something a little different, just so we've seen some different things. Let's say we had 3x squared plus 10x minus 300 equals 15 minus 2x squared. A little longer problem, but squared up there. 3x squared plus 10x minus 300 equals 15 minus 2x squared. So that's, is it any harder than the other ones? No, it's just a little, it's more complicated because there's stuff to do. That's what I'm trying to get out at you here. So what do we need to do with this one? Yeah, subtract 15 from the 300 and add 2x squared. So I'm okay with you doing those two steps at once right there, because that's what gets you equal to 0. And that's, you know, first thing you should do if you're solving by graphing. I mean, solving by factoring, then getting it equal to 0 is the key. Technically, if you solve by graphing, it is too. But that'd give us 5x squared plus 10x minus 315. Ooh, big numbers. But what's the first thing you do? What is the GCF? All right, 5 goes into them. Does everybody have an X? No, the 315 doesn't, so that messes up having the X. So 5 is the GCF, so we're going to pull that 5 out. And what does that leave in the parentheses then? Okay. Will the part in parentheses factor further? It's a trinomial, so we've got to try to do it with what method? X method. So we're looking for negative 63, add to be 2. 7 and 9. Which one did you say was negative? Negative 7. So that it would add to be positive 2. Okay. Can we take the shortcut on this part? Yes. The 5 is no longer part of this thing. It's out here in the front. So there's nothing really in front of that x squared except for that 1. So that allows us to take that shortcut here and get x minus 7, x plus 9. And then the 5 technically is still there. How do I get rid of that 5? Because it doesn't have a variable, does it? I don't want to distribute it because then I end up back closer to what I started with. I can't divide it by 0, but I can divide. I know what you mean. You divide it into 0. That's the right idea. Good job. If I divide both sides by that number that's out there, it gets rid of it. If that GCF doesn't have a letter, then it really doesn't affect anything as far as the answers go. It affects the graph of the quadratic, but it does not affect where the quadratic technically crosses the x-axis. That's what we're finding here. So, but this is the math that gets rid of it. You can just kind of hand wave that and say, oh, well, that 5's gone because it doesn't even have a letter. And then you set just the factors that have variables equal to 0. And you get x equals 7, x equals negative 9. All right. Let's do one more. We'll do a tough one. We'll be done, okay? We'll do the hardest one I can come up with. Well, maybe not the hardest one I can come up with, but one that's a little bit more difficult than the ones we've been doing. All right, let's see. What letter are we on? F. That's fitting for factoring. No, don't say that. Yeah, let's do that. All right, first thing. You get like terms together, right? And get it equal to what? 0. So, there's 3 things on this side, 2 things on that side. Technically, it doesn't matter which side you move to, but it seems shorter if I move these 2, right? Than move the next 3. So, how do we move the 2x squared? How do we move the 3x? Add it. Okay. There's our 0. So that gives us what trinomial to work with here? 5x squared minus 17x plus 6. Ooh, that looks nice. Yeah. So if you do the right stuff at the beginning, then it turns into something you've probably done before. Okay. What goes up top? Positive 30, negative 17 in the bottom, 15, negative 2. Again, I'm going to do it different this time because I'm bored. To show that it doesn't matter what order you put that in, it still works. Okay? I put the negative 2x first. It doesn't matter. If I group the first 2 together, what's the GCF of these 2 that I'm using? X, leaving 5x minus 2 in the parentheses. And then the second set, what kind of 3? Remember that sign right there tells you to pull a negative 3, and that leaves you 5x minus 2. Factoring is still 5x minus 2 and x minus 3. Those factors are still the same as they were when we did it earlier. Just we started out in a different order. It still works. And we set those equal to 0. Add 2. 5. 2/5. And 3. Okay. Solving by factoring doesn't get any more difficult than this for quadratics. When we start doing polynomials in a couple of weeks, or maybe the end of next week, I'm not sure yet. When we start doing those, some of these same techniques are going to come in. The higher degree polynomials, yeah, that gets a little tougher, but the quadratics, they're not getting any harder than this, especially solving by factoring. So kind of the lay of the land where we're going with this. We're going to solve by factoring today, finish that up tomorrow, and then next week we'll do the other methods of solving quadratics because we're going to need those to do higher degree polynomials. So we'll do quadratic formula, square roots. We'll talk about this thing called completing the square, and then we'll take a test over solving quadratics, period. And then we'll do graphing quadratics, and then we'll get the higher degree polynomials after that. Okay, so Khan Academy is where your work's at. There's several lessons there that I've already assigned to you on there that you can work your way through, and